Okay, so the last form of analysis that we're going to go over, it's called multivariate analysis. And what a multivariate analysis is, it's basically just, hey, we're going to take a look at multiple features, multiple variables. So let me go back and clear everything in our pivot table for right now. And actually, I'll keep age category here. So I'll keep age category here. And what I'll do is I'll look at score text here for my columns. And I'll also take a look at score text for the values. And under age categories, what I want to know is I want to know whether these people actually committed another crime based on their age with respect to what the algorithm predicted. So I'm analyzing three features here. Let me clean this up. I want to get rid of blanks. Okay, actually, let me look at the is recidivism field. I'm going to get rid of minus ones and blanks in the is recidivism field. Okay, so that's much cleaner. Okay, so let's take a look at this. I am now analyzing three columns, right? What the algorithm predicted, high, medium, or low, with respect to age category, with respect to whether they actually committed a crime or not in the future, 2 years after they were released. And what I'm most interested in is based on age. For instance, between 25 and 45, the algorithm predicted that 1,228 people would commit another crime if they were released. But in reality, only 654 of those 1,228 people actually committed a crime. That's an insight from multivariate analysis. I would probably take this and mark that red because that's a mistake. It predicted 1,558 people would commit a crime with medium certainty if they were released, and only 668 of them actually did. I don't think that's really not a great percentage. It's not a great percentage. Look over here, it's the same thing, right? Predict 207 people over 45 would commit a crime if they were released, when in reality only half of them did. Actually, let me go back because I said something incorrect here. I said something incorrect, and I need to fix that. Okay. 0 means they did not commit a crime. 1 means they did commit a crime. So let me be accurate here. 574 people did not commit a crime when the algorithm predicted that they would. There is the mistake right there. I apologize about that. Same thing over here. 920 people, the algorithm predicted that they would, with a medium degree of certainty, commit a crime, and only 920 of them did. There's the insight. That's where it got it wrong. This is where it got it right. So let's put green where it got it right. Okay. It predicted at this age group right here, 25 to 45, it predicted 3,456 people would be low, meaning they would not reoffend. And so they got it right there. And it predicted 827 people would not reoffend. I'm sorry, 3,456 people would not reoffend, and 827 of them did. All right, so that's what this looks like right here. These are all of the mistakes in the algorithm, and we can do this with all of them here. Red, 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 mistake, red, red, red. These are all mistakes. and the green would be here. I'll make this a little greener. Here, here, here. These are all the ones that the algorithm got correct. Okay, so these are all of the insights that we can pull from a multivariate analysis by analyzing 3 columns of data here. And here's the thing about this. If I wanted to view this, let me just see for high, for instance. Again, if I just wanted to look at the, I want to analyze, hey, how did the algorithm do with respect to predicting high? And if I look at this over here, I'm going to go to value field settings, show value as, and let me look at the percent of column total first. And see, just in terms of when the algorithm predicted high, how many times did the algorithm get it correct? High, again, means that a high degree of confidence that whoever was arrested would commit a crime if they were released. And if you look there, you can see that the algorithm was wrong 27% of the time. Out of all the times that the algorithm was wrong, all of the predictions, 27% of them were in that age group 25 to 45. 27% of the time that the algorithm was wrong was in that age group 25 to 45. That's an insight. Greater than 45, it was only wrong 5.67% of the time. And less than 25%, it was 14.29%. Okay. That's analyzing just the highs. And if I wanted to analyze the columns, same thing. Value field settings, show value as. I might want to do this as a percent of the row total. Okay, so if I'm looking this way, I can say that for all of the times that the algorithm predicted, for all of the people, let me see, 22, 63. Okay, so 22, 32, I'm adding these 2 numbers here, 22, 32, 35, 36. About 36% of the time, the algorithm, frankly, was wrong. It was right about 63% of the time. These are people that did not reoffend. Out of all the people that were between the ages of 25 and 45, about 22, 32, 35, 30, about 36% of the time, the algorithm predicted that they would. That's an insight. Less than 25, the numbers are even worse. What, 33? So if you didn't reoffend and you're less than 25 years old, the algorithm predicted what, 33, 43, 53, 55, 56. More than half the time, less than 25, you're less than 25 years old, you wouldn't reoffend, but the algorithm would predict that you would reoffend. That's an insight. I want to look at this as percent difference from, let's say, greater than 45. I would go to value field settings, show value as, percent difference from, let's say, greater than 45. Percent difference from the greater than 45. Okay. So you can see here that 25 to 45, the algorithm is significantly worse with respect to greater than 45. It's also pretty bad with less than 25. But it's 382% more likely to make a mistake if you're between 25 and 45 than if you're greater than 45. We did age category. You take this data, if you look at this data with respect to race, for instance. Let me go back here. That percent difference from, no calculation. No calculation is what I'm trying to do. There you go. Okay, so same thing here, right? You can see this is what the algorithm predicted by race. Okay. And you could go through the same thing. You can just look at a column, value field settings. I'm looking at 3 features, so it's a multivariate analysis. Show value as, just look at the columns. Percent, actually let's look at percent of grand total here. And then you just look for outliers. So if I'm making or finding insights here, almost 14% of all of the high predictions are for African Americans, and 0.08% of all medium predictions are Native American, and 0.36 of all low predictions are Asian. This is for the total data set. 19% are high, 56% are low, 25% is medium. If I looked at this with respect to show value as percent of the column total, I'm just looking at this column here. Just looking at this column here. And for all of the highs, 73% of all highs, the algorithm predicts, if it's predicting that it's a high, then 73% of the time it's going to be predicting an African American, 19.87% Caucasian, Hispanic, etc., etc. If the algorithm predicts low, then 41.38% of the time it's going to be Caucasian, 37.72% African American, Hispanic, etc. If you look at this from a, and by the way, these are the areas that are wrong too, by the way, right? So if I look at this here, these are the errors. Make this red. These are the errors, right? It predicted that this group, this demographic, would commit a crime, and in reality they did not. This is a mistake in the algorithm. This is a mistake. This is a mistake. Even this is a mistake here, right? That's a mistake. Mistake. Here, I'll just highlight all the mistakes again. At least for me, this helps me. All right, sorry, I know you don't like wasting video time watching me do paint by numbers, but I'm almost done. But anyway, these are all of the mistakes, right? So these are all insights that you can pull, right? I can look here and say these are correct. It predicted high that this demographic would reoffend if released, and sure enough, that's what happened. These are all correct. I'll paint these in. Okay, so as I paint these in, you can start to look and see what insights you can discover from from this multivariate analysis. But by this point, I think you get the picture by now. You could look at this here and see that make statements like the algorithm is what 3 times as likely to make a mistake on African Americans than Caucasians with respect to predicting whether they will commit a crime if they're released. So it's 3 times as bad here. It's that's an insight that you can pull. If I looked at this value field settings with respect to show value as, instead of by column, if I looked at this as a percent of the row total, look at this, it tells another story here. These are insights I can pull as well from this. I could look at this and see same thing, right? It's still 3 times as likely to make a mistake, right? Between here and here, it's 3 times as likely to make a mistake. And it's also 3 times as likely, it still makes a big percentage mistake here, right? You can notice the differences in the mistakes that the algorithm makes. Right. So anyway, that's what a multivariate analysis is all about, being able to pull insights from 3, and we can add on to this, and I'm doing what by race. We could do by race, and this is a multivariate analysis, so we might be able to add. Yeah, right here. Yeah, maybe just the other way, like that. Yeah. Okay, so multivariate analysis, right? We have 4, right? Now we have 4 features that we're looking at. We're looking at whether they committed a crime, is recidivism 0 or 1. We're looking at sex. We're looking at race, and we're looking at what the algorithm predicted. So we can still see the mistakes now. Okay. In the algorithm, and these are all the insights that we can pull, and now we're pulling these insights based on 4 features. Okay, so that is, I think I'm going to stop here. Let me stop sharing my screen. Okay. I think I'm going to stop here, but I wanted to just kind of do a real, super quick recap. We looked at univariate analysis, and we said that a univariate analysis, is basically taking one column of data and looking at the distribution of that data, looking at the central limit theorem and what we can pull from central limit theorem from that data. That's what univariate analysis is about. Then we went in and we looked at 2 columns of data to see what kind of what kinds of insights we can pull from the relationships between 2 columns of data. And then we looked at a multivariate analysis where we can look at 3 columns or 4 columns or as many as your brain can fathom. So this is just one data set. The most important thing that I would ask you to to leave with this is that, importantly, these are techniques that will apply to literally any data set. Any data set. Don't get stuck on just this data set. These principles that we talked about are universal. These are the steps that you must do prior to loading your data into Tableau, using it in Python, loading this data into Power BI. This is the thinking part of it, right? This is the data analysis from an exploratory perspective. Okay, so with that, I hope you got some value out of our time together, or at least watching this video, and I will see you on the other side. Thank you.